Right now, floating in space, there's a telescope that was sent up for one job: to confirm we'd figured out the universe correctly, to prove our physics textbooks were right. Instead, it broke everything. It found a star that isn't burning fuel, it's burning dark matter. It found galaxies that aren't galaxies at all. It found a planet that should have lost its entire atmosphere billions of years ago and somehow hasn't. And it watched 5 galaxies slam into each other at a point in cosmic history when that collision shouldn't have been physically possible. This telescope is the James Webb Space Telescope, the most powerful one humanity has ever built. And the 5 things it just discovered are quietly rewriting the rulebook on how stars ignite, how galaxies form, and how planets hold on to their air. Before we get into it, if you're new here, hit subscribe and turn on notifications so you don't miss what's coming next. Now, let's get into it. The rules we thought were unbreakable. For decades, scientists relied on a framework called the Standard Model of Cosmology. It lays out a few basic, dependable rules. Rule 1. Galaxies take billions of years to form. Gravity is slow. Our own Milky Way took roughly 13 billion years to come together. Rule 2. Stars shine because of nuclear fusion. A cloud of hydrogen collapses under its own gravity until it's hot and dense enough for atoms to fuse, and that fusion is the light we see. Rule 3. Black holes grow gradually. As a black hole feeds, the material falling in heats up and radiates light, and that light pushes back, choking off the black hole's own food supply. This is called the Eddington limit, and it means becoming supermassive takes billions of years. Rule 4. Planets inherit their chemistry from their star. A planet and its star form from the same cloud of gas, so they should share the same chemical ingredients. Keep these 4 in mind. James Webb is about to break every single one. Discovery 1. A star that doesn't burn like a star. Webb pointed itself at one of the oldest corners of the universe and found an object called JADES GSZ 140. Its light is only 300 million years younger than the Big Bang itself, essentially baby pictures of the cosmos. According to the standard rules, anything this early should be small, dim, and barely forming. But this object was bright, compact, and calculations suggested it contained the mass of hundreds of millions of suns. That's the problem. There's no known way to gather that much matter that fast. Using Webb's spectrograph, a tool that breaks light apart into the 85% you can't see. In the 1930s, astronomer Fritz Zwicky studied a massive cluster of galaxies and found something impossible, labeled the JWST Quintet, 5 separate galaxies crammed into a tiny region actively colliding, their gravity tearing into each other. Using a tool called an integral field unit, which essentially creates a 3D map of every element across the entire scene, scientists found something they didn't expect: a massive shared cloud of gas connecting all 5 galaxies, plus a clear signal of ionized oxygen spread across hundreds of thousands of light-years of empty space between them. Here's why that matters. The Big Bang only produced hydrogen, helium, and trace lithium. Oxygen has to be forged inside massive stars and then blasted into space by supernovae, a process that takes generations of stellar life and death, plus thousands of overlapping supernova explosions to push that oxygen out of a galaxy entirely. Add it all up, forming massive stars, their deaths, a second generation of stars, more deaths, galactic winds strong enough to expel oxygen, and 5 galaxies finding each other across the cosmos to collide, and 800 million years simply isn't enough time, yet here it all is. Discovery 4. A planet rebuilding its own air. Closer to home, just 280 light-years away, sits TOI 561, a star nearly 10 billion years old, almost twice the age of our Sun day. Orbiting it is TOI 561b, a super-Earth that completes a full year in just 10.5 hours. It's tidally locked one side in permanent daylight, the other in permanent night. Webb stared at it for 37 hours across 4 orbits to measure its dayside temperature. If this were... Let that sink in. 95% of the universe is something we cannot directly observe or fully explain. The voids no one talks about. It gets emptier still. When astronomers map the positions of galaxies across space, they discover galaxies aren't scattered randomly. They form a cosmic web of filaments and clusters, separated by massive voids containing almost nothing. In 1981, astronomers discovered one such void in the constellation Boötis, a region roughly 330 million light-years across, containing only about 60 galaxies, where a typical region that size would hold around 10,000. That's 99.4% emptier than expected. And these voids aren't shrinking, they're growing. As dark energy accelerates expansion, matter has less time to drift from empty regions into denser ones. The cosmic web is slowly being stretched apart permanently. Why this moment in time is so rare? Here's the part that should really make you pause. The universe is roughly 13.8 billion years old. Stars will keep forming for at least another 100 trillion years, meaning we're in the first 0.01% of the era when stars even exist. Right now, distant galaxies are visible. The afterglow of the Big Bang is still detectable. We can still measure the universe's history and predict its future. But as expansion continues, galaxies will cross a cosmic horizon and vanish from view forever, not because they stop existing, but because light from them will never reach us again. Eventually, even our own galaxy's merger with Andromeda will be the only structure left visible in the sky. Everything else, gone, swallowed by expanding darkness. One more thing before we wrap up. This is exactly the kind of universe most people never get explained to them in plain terms. If this blew your mind even a little, smash that like button and subscribe so you don't miss the next deep dive. It really does make a difference for this channel. Why this should change how you see everything. So, why does any of this matter? Because the conditions required for galaxies and for us to exist are absurdly specific. If the early universe's density variations had been even slightly larger, everything would have collapsed into black holes, slightly smaller, and matter would have spread too thin for galaxies to ever form. The emptiness isn't a flaw in the universe. It's the reason structure, galaxies, stars, planets, life was able to form at all. Too much density and there's nothing but black holes. Too little and there's nothing but gas drifting apart forever. That's the real takeaway. Not that the universe is empty, but that despite the emptiness, despite the odds, despite 95% of everything being a mystery we can't see or touch, we're here. We're looking up.